Right, fourth video on the review of topics 1.1 to 1.6. This one says that there's a polynomial, which of the following statements is true about the zeros of this polynomial. All right, there are 8 distinct real zeros, 4, 3, and 2 non-real. Okay, all right. So it is clear that what are the roots, by the way? Roots are obviously all the points where these factors are 0. So the first factor, I just ignore the power because that just indicates multiplicity. So x is equal to 0 is one root. X square plus 0, 4 is 0, which does not really generate any real root, right? Because I will say that x square is negative 4, and that would make x as plus minus 2i. Then the next factor, x minus 3 is 0, which makes x as 3. And then the next factor, x minus 1 is 0, which makes x as 1. So I have 1, 2, and 3. Three distinct real zeros, which is right here, and two distinct non-real zeros, which is right here, two non-real zeros. So I think C is the best choice. Over here, we need to figure out during which interval is gx greater than equal to 0. So I think we have done these questions. So the way we used to do this is 2x squared plus 5x minus 12 equal to 0. We will factorize this completely, right? You have to factorize this. So in order to factorize, let me try to make some more space here. Okay, in order to factorize this, we'll use the x method. So we make x here. On the top, it's 2 times negative 12, which is negative 24. At the bottom, we have 5. And what two factors of negative 24 add up to 5? 8 and negative 3, I think. 8 and negative 3. Then using this 8 and negative 3, I will split the middle term. So 2x squared plus 8x minus 3x minus 12 is equal to 0. So 2x, x plus 4 is out, and then minus 3x plus 4 is out from here. Why am I putting equal to 0? I have to solve for greater than equal to 0, right? So let's change these signs, greater than equal to 0 and greater than equal to 0. And now if you remember, we used to make a number line where on the number line we will plot the zeros of the individual factors. So what is the 0 of this? That's 3 over 2. And what is the 0 of this? This is negative 4. So I put any number greater than 3 over 2, maybe 100. So 100 will make, obviously 100 times 200, and 200 minus 3 is positive, and 100 plus 4 is positive. So this is positive. And if I put 0 here, 0 minus 3 is negative, 0 plus 4 is positive. So negative times positive is negative. And then less than negative 4 is, let's say, negative 100. So negative, negative, and double negative is positive. I'm looking for greater than equal to 0. Equal to 0 is also allowed. So my answer is negative infinity to negative 4 bracket union bracket 3 over 4 to infinity, because obviously 3 over negative 4 and 3 over 2 are allowed. So this is our final answer. Okay. The polynomial function h has zeros this and this and this and this. What is the least possible degree of h? So obviously x equal to 3 has a multiplicity of 2, which means that x minus 3 has a power of 2, right? Likewise, x plus 4 has a power of 3 because it has a multiplicity of 3. I'm just showing this so that you understand, but ideally to solve the question, I just need to count the multiplicities, which is 2 here, 3 here, so 2 plus 3 for the degrees. And then remember that complex roots always occur in conjugate pairs. So although 2i is a one root, but we know that x minus 2i or x equal to negative 2i is another root. So two roots from here. And since 5 minus 3i is a root, likewise a conjugate 5 plus 3i will also be a root. So two roots from here, 1 and 2, and then 1 and 2. So the least degree is 5, 6, 7, 8, 9. So the option is, correct choice is option D. Over here we are given a graph and they're asking that the rate of changes of h is, okay. We know that h is decreasing in nature here. We can see that h is decreasing. So rate of change is definitely negative because ROC negative means the function is decreasing. So since the function is decreasing, ROC is negative, so rate of change is negative. C and D are saying the function is negative. That doesn't make any sense because the function is above the x-axis, so it is positive. So that's not true. And then rate of change of H is positive, is negative. So I think only B is matching, right? And it is ROC is also decreasing because ROC decreasing means the function is concave down. And indeed, the function is concave down. So the best choice is option B. Right, on this question, we have to find which of the following statements are true about the zeros in multiplicity. Okay, so for the first factor, x squared minus 9 equal to 0, I have x squared, or this can be factored as x minus 3, x plus 3 is equal to 0. So from here, I have x is equal to 3, and from here, I have x is equal to negative 3. So the multiplicity is 1, and the multiplicity is 1 over here. Okay. For the next one, I have x plus 3 whole square is equal to 0, which means that x is negative 3 and the multiplicity is clearly of 2 because that's a square over here. And then the last one, x squared plus 6x plus 9 is equal to 0. So this is x plus 3 whole square is equal to 0. So clearly x is negative 3 and the multiplicity is 2. Right, let's count the zeros. We have negative 3 here once, the negative 3 two times, and the negative 3 two times. So 2 plus 2 plus 1, 5. X equal to negative 3 is with a multiplicity of 5. There you go. It's an option A and an option D. And x equal to 3 is just with a multiplicity of 1, which is clearly not option D because D says it is with a multiplicity of 5. This is just x equal to 3. So the correct choice is option A. All right. Selected values of G are given, which of the following could be true. G is an odd function and G is an even function. So the first fight is between odd and even. So we know that odd and even happens when if there is a change of sign in the X, then there's a change of sign in the Y as well, which I can see is happening because they're asking could be. It's not mandatory because we don't know how the other points are behaving. But definitely this cannot be even, right? So if I'm given a choice of even or odd, obviously I will pick odd because negative 1 to 1 and negative 3 to 3. So it has to be an odd function. And G is concave down or concave up. So for that we need to find the average rate of change. So what is the, and we can clearly see that the X is increasing by the same value, so we don't have to worry about that. So let's find the difference between negative 12 minus minus 13 is 1. And negative 8 minus minus 12 is 4. Negative 3 minus minus 8 is 5. 3 minus minus 6 is 6. Sorry, 3 minus minus 3 is 6. And we can clearly see that AROC values are increasing in nature. And whenever average rate of change at the first difference keeps increasing, it is concave up. So it has to be option D. Sorry, what am I saying? It has to be option B because it's an odd function and concave up. Right, f is even, find the value of a plus b plus c. I can do that. So f is even means even if I change the sign of negative 6 to 6, the negative 4 will not change. So negative 4 will remain 4. Sorry, negative 4 will remain negative 4. So c is negative 4. Likewise, I look at these two numbers. Even if I change the sign of x from negative 2 to 2, then 1 will not change. So a will still be 1. And likewise, if I change the sign, if I look at here 5 and negative 5, sorry, of course not 5 and negative 5, 5 and 5, because in even function the y value doesn't change, so this is not changing, but negative 3 will change to positive 3, so b will become 3. They're asking what is a plus b plus c. Clearly that's 0 because negative 4 plus 1 plus 3 is negative 4 plus 4, which is just 0. For here we need to find whether the function first option is increasing or decreasing, clearly decreasing. This is descending curve, this is going down, so it is a decreasing curve. And this is concave up, right? And concave up function is increasing rate, so it has to be option C. And over here, how is the function behaving? H is increasing in nature, of course. So it is increasing. It has to be either A or B because it is climbing clearly. And it is also a smiling face function. So it's also increasing rate. So it has to be option A over here. Right here, once again, it is increasing or decreasing. So haven't we done this? No. Okay, no. Uh, H is increasing clearly. It is climbing. So it has to be either A or B. And this is concave down, right? This is frowning in nature. So it is increasing at a decreasing rate. So it has to be option B. Right. End behavior of the polynomial. So this is an odd function. I mean, odd degree with a positive leading coefficient. So odd degree with it just means that I need to focus only on this. And if x becomes more and more positive, obviously this will become more and more positive as well. So if x is approaching infinity, the limit should approach infinity. So infinity infinity combination is here. And if x approaches negative infinity, then obviously this negative raised to 5 is also a negative number. So the negative will come out. Y will also approach negative infinity. So negative negative combination is over here. So the answer has to be option B. Okay. Here we don't really know the degree in a straightforward way at least, but we can add the individual degrees, which is 1 from here, 2 from here, and 3 from here, which is 6. And negative 2 is obviously just negative 2, so that's the leading coefficient. So negative 2x raised to 6. And we know that it doesn't matter whether x approaches to positive infinity and x approaches to negative infinity. The answer has to be negative because a positive or negative number raised to an even function is positive, and positive times negative is a negative number. So it has to be negative, which means that both should be negative infinity, which I am seeing only in option A. Whether x approaches infinity or negative infinity or infinity, the answer has to go to negative infinity. So it has to be option A. F be an odd function and f of negative 4 is 5 is the local minimum of the function, then which of the following must be true? This is based on the graphing properties of the odd function because we know that the odd function is symmetric about the origin. So if negative 4 comma 5 is a point, which is here, which is a local minima, by the way. So it must have behaved like this over, at this point, negative 4 comma 5. And we know that if negative 4 comma 5 is a function, 4 comma negative 5 will also be a sorry, 4 comma, if negative 4 comma 5 is a point, then 4 comma negative 5 will also be a point. And since this is symmetric about the origin, it's something like I reflect about the y-axis and then I reflect about the x-axis. So it will become something like this, which is obviously a nature of local maxima. So f of 4 equal to negative 5 is a local maxima because f of 4 equal to negative 5 is a fancy way of saying that the point is 4 comma negative 5, right? Okay. We are given a piecewise function and we need to find AROC in 0 to 5. So for that, I need to find what is the value of h of 0. So h of 0 is x is less than 4 already. So h of 0 will be 3 times 0 square plus 1, which is 1. And h of 5 will be 4 times 5 minus 9, which is 20 minus 9, which is 11. 20 minus 9 is 11. So AROC is going to be AROC is going to be h of 5 minus h of 0 over 5 minus 0, which is 11 minus 1 over 5, which is 10 over 5, which is just 2, which is option A. Should be the correct answer. Right. Again, a similar question to, yeah, to 14. First, we need to figure out what is h of 4. So be careful where 4 is included here. So we need to use this function. So h of 4 will be 4 times 4 minus 9, which is 16 minus 9, which is 7. And h of 6 will be also this one because 6 is greater than 4. So 4 times 6 minus 9, which is 24 minus 9, which is, I think, what, 15, right? Yeah. So AROC is going to be h of 6 minus h of 4 over 6 minus 4. So 15 minus 7 over 2, which is, I think, 8 over 2, which is just 4 over here, which is option B. Okay. Now we are given a graph and we need to figure out which of the following could be that polynomial. So first I need to check the degrees, sorry, roots. That's the first way I will rule out. So 0 is a root, which is in all the options. A positive root, I don't know what that is, but there's a positive root and then there is a negative root. Unfortunately, all of the options are with the same situation. Now I check the multiplicity because I know that x has to be an even multiplicity because it bounces at this point. So it cannot be a or b because x is with an odd power. So a and b are not possible. And between C and D, there is no difference in the multiplicity if you see. I mean, it's exactly the same expression except this negative sign. So that's where I need to check the the end behavior. So clearly this is going down and up. On the right, it is going down. So if on the right it is going down, the leading coefficient has to be negative, right? So it should be option C. Okay. In which intervals is gx negative? So I think this is similar to what we did earlier. Let me continue here. Negative 2x, x plus 4 whole cube, x minus 7 whole raised to 4. So over here, I think I'm gonna just plot the zeros. So x equal to 0 is 1, 0, x equal to negative 4, and x equal to 7. But I think we forgot that the first situation, the zeros are not wrong, obviously they are correct, but first step is to make the leading coefficient positive. So this is less than 0, but I need to multiply negative sign both the sides to rewrite it with a positive leading coefficient, and remember that the inequality sign will also change. Right, I'm going to make a number line now and plot these zeros. So negative 4 is here, 0 is here, 7 is here. And then I put, some random numbers in these interval. I don't even think I need to worry about this because this is an even power. And even power is always positive. So I won't really even ask the sign of this. I'll just concentrate on the remaining two terms. Any number greater than 7 may be 100. So if I put 100 here, this will be positive. Any number between 0 and 7 may be 1. If I put 1, this will again be positive. Any number between 0 and negative 4 may be negative 1. If I put negative 1, then although this is positive, 4 minus 1 is 3, but this is negative. So here negative. And any number less than negative 4 may be negative 100. So this is negative, and because it's an odd power, right? And double negative is positive. So the only answer where gx is negative 4 to 0, which is option A. All right. I think I'm going to skip these questions because this is similar to just plotting. If you need more help with this, there is a video 1.1 to 1.6 part C. In that video, I have shown TI-84 as well as on how to plot these and find these solve questions like these. So you can refer to that video. Uh, for the function g in the problem 19, which is this, what is the complete interval? So that's the same thing. That's an extension to the same question. So again, you can refer the same video 1.1 to 1.6c. This is also on the same situation. So 1.1 to 1.6c. And there you go. We'll try these. We need to factor this completely. So we need to use the the theorems, the properties that x square minus 9, so that's the difference of perfect square identity. So it's x minus 3, x plus 3. And here I think that's pretty easy to factorize because negative 6 and 3 are the two factors. So the x minus 6 and x plus 3 are the factors. And there are two x plus 3, so these can be clubbed. So the final answer is x minus 3, x minus 6, x plus 3 whole square. Over here, again, we need to make x. Negative 8 times 3 is negative 24, and this is negative 2, which to, I think, 6 and 4, right? Or negative 6 and 4, because negative 6 and 4 when added becomes negative 2. So this can be written as 3x squared minus 6x plus 4x minus 8. From here, 3x can be taken as a common factor. I'm left with x minus 2. And 4 can be taken as a common factor. I'm left with x minus 2 again. So x minus 2 is again taken as a common factor, and I'm left with 3x plus 4. So that's the final factorization. Over here, I can take x as a common, in fact, 2x as a common factor. So I'm left with 2x squared minus 5x minus 12. And once again, this is the x situation where we make x, and here we have negative 24, here we have negative 5, here we have negative 8, here we have 3. So the answer is 2x, then 2x squared minus 8x plus 3x minus 12. It will be 2x, and then from here I take 2x as a common factor. I'm left with x minus 4, and then 3 as a common factor. I'm left with x minus 4 again. So I'll be left with 2x, 2x plus 3, x minus 4. That is the final answer. Over here, we need to figure out where is kx greater than or equal to 0. So let's factorize this. 23. Let's take x squared as a common factor. So I'm left with 2x squared plus 9x minus 5 is greater than or equal to 0. We need to make x again. So this will be negative 10, this will be 9, this will be 10, this will be negative 1. So this will become x squared, 2x squared plus 10x minus x minus 5 is greater than or equal to 0. So x squared, 2x minus 1, x plus 5 is greater than or equal to 0. So over here, I make a number line. Here I have negative 5, here I have 0, here I have 1 over 2. I'm not really bothered about x squared because that's always positive. So let's put a number greater than 1 over 2, maybe 100. So this is positive, this is positive, positive. 0 to 1 over 2, maybe 1 over 4. So this is positive and this is negative. Negative 5 to 0, maybe negative 4. So this is negative, but this is positive. So positive and negative is negative. Any number less than negative 100, negative 5 is negative 100. So negative, negative, and double negative is positive. I need greater than or equal to 0. So the answer is negative infinity to negative 5 union half to infinity. Okay. Finally, we need to write two limit statements to define the end behavior. So that's pretty straightforward. I know that when limit when x approaches infinity of the function h, the function goes to negative infinity, because as x is going on the right, the function is descending. And likewise, when the function x is going in the negative side, which is over here, of course, the function is still descending. So it is again going to negative infinity over here.